um, overturning. So you have to increase the dimension of the dam. And if it is not also, if the foundation of the dam is also, or the soil foundation cannot resist all the forces on the dam, you have to increase the width, no? Increase the width of the dam. So mudako ang imuhang width sa imuhang dam minus ang imuhang soil. Okay, so what are the forces? You have these forces. So the upstream side, this is an example of or forces acting on a gravity dam. So when you say gravity dam, this is constructed using concrete, using stone masonry, just to hold back the water. And it only used its own weight to resist all of these forces against the resistance of its foundation against sliding and of this pushing of the pressure of water. So only the weight of the dam ang iyahang kuan. Nag-rely lang siya sa iyahang self-weight. Okay, so that is one of a dam, that is gravity dam. So upstream side, that is you have a headwater. So sa upside, headwater ang tawag ana. Sa downstream side, you have a tailwater. So kung nakay tubig sa imuhang downstream side, okay, for example, you have that one. So downstream side, you have a tailwater there. Okay, so in order for you to solve this, kanang masayon-sayon solve, so you have to divide the cross section into a section that you can easily find the center of gravity because you have to take moment about the two. So just imagine your feet, no? Imuhang imuhang tiil, na kay heel, na po kay two. So sa na kay tikod, na po kay two. So kung ituklod ka, diba? Unsa may mitabo kung ituklod ka. So sa edge nimo sa imuhang two, mo overturn ka diha. So pareha ra pod nang sa tubig, no? Ang imuhang pressure sa imuhang tubig, i-push ang dam. So mo overturn ang imuhang downstream side edge or sa two side. So mo take in, di ba? Mo kung itulod ka mo rakag mo applique mo lift ang imong heel, then mo tukod ang imuhang two. So kung ang pressure hinay lang, dayon ang imong pagtulod hinay lang, kung sa weight sa imuhang sa tawo nga imong gitulod, so unaffected. Pero kung kusog imong pagtulod, dayon ang imuhang gitulod gamay lang kaayo, gaan siya or di kay siya dako, no? So may tendency nga usamod siya, magumba, manana ang kuan, ang concept. So you need to divide nga makabalor mo dayon sa center of gravity. So that is the location of the weight. So at the center of gravity. So from the center of gravity, you have to take moment about the two side. Okay, so if you remember in your fluid mechanics, the vertical projection of the dam is a rectangular. So, mo ni siya vertical projection sa imuhang dam. So, you have there, to determine the pressure you have the formula F is equal to, provided your vertical projection is rectangular like this, that is equal to gamma h times area. So your bar h, that is from the center of gravity to the water surface. So this is how you are going to compute the horizontal force or the forces acting on a plane surface or the horizontal force. Okay, so you have that one. Or you can also, okay, so if we will derive the formula, so we have gamma h over 2 because that is equal to h over 2. The area is equal to a base times height times 1 meter. Ito ba? Okay. So, 1 meter naman na siya. So, base times height. So, we have, okay, times, okay, time, 1 time, h times 1. So, your force is equal to gamma, okay, 1/2. Because you have to compute the forces per meter width. So, that's why the length, the width, no, width is 1 meter. Imuhang length sa imuhang dam here, pwede man siya i-denote na to as B also. So, ang quantity is per meter length. So, perpendicular to this, the screen, kanang perpendicular sa inyong screen diha, per meter width ana ang inyong pag-design is per 1 meter length. No? So, the length is perpendicular sa ato ang screen. Una siya ato ang length. So, you can have this 1/2 gamma h squared times 1. So, you have that formula. So, then you get the forces or you design or you analyze the dam per meter width. So, that is the width perpendicular to the screen. The same for in the foundation or the footing. So, you have to take the the footing of the wall footing. Sorry, that when you design the wall footing, so ang pag-design sa wall footing, you have to consider only 1 meter width or 1 meter length. Length. Okay, so you have that formula that is equal to 1/2 gamma h squared times 1. So by applying also the pressurism formula, as force acting on a plane surface, okay, so here your pressure is 0. We let that one as P1 because it is exposed to atmospheric pressure. Then as you go deeper, your pressure will increase. It will increases with depth. So the formula is gamma times h at that point. So on side depth, if you like to determine the pressure for a certain depth, you have to multiply the depth by the specific weight of the fluid. So to determine the formula, you have the formula of a triangle. So let's say force is equal to 1/2 times P1. So if we let it as, no, kung naa siya pressure diha, for example, you have, but your P1 is equal to 0. So, okay lang, may P1 plus P2. Or you can directly 0 or triangle. This one is trapezoid man eh. Pero ang P1 is equal to 0. So, mo result to dyan po siya triangular nga po. Sige, ato na lang siya i-resolve. So, the first is equal to the area of a triangle P2 times H times 1. So, your P2 is equal to gamma H times 1. So, this gives the same formula, H squared times 1. So, you have the same formula for your pressure. Tag-asa inyong gamiton anak, kasi muna siya o answer. Okay, so this one, ako ni i-reason. This is the seepage. So that is the uplift pressure. The uplift pressure is the pressure due to the seepage of the water. So ang imuhang tubig sa upstream side mo, kung ang imuhang foundation at the base of the dam is not impermeable. So permeable ang imuhang kuan. So there is a possibility to seep down. So it makes your dam also to overturn because of the uplift pressure. Okay, so here, the pressure here is also, whatever the pressure of that hydrostatic pressure is also equal to the pressure of your uplift pressure at that point and also to this point. So that is also equal. So to determine the pressure or the uplift pressure, you have to divide again so that you need to divide to a section that you can easily determine the center of gravity, or else if you know the center of gravity directly of the trapezoidal, so you can do it also. If not, you have to bisect the section. Okay, again, that is the seepage or the uplift pressure. The water is the hydrostatic forces. So, muna siya force due to the water. Okay, so there are some also forces that may act to your dam. So you can add everything. So pwede na, no, you have here the wave. You also have the earthquake load. You have the other load on top of your dam. Kaya pwede man, no, ang butangan nila na o pwede nimo siyang maagian ba. Depende on sa type sa usage. So, pwede na nimo i-add on. So, ang kani, you can add that one for your weight, additional vertical force. So, ang imo hapong diri sa lateral load nimo, it can be the earthquake load, it can be the wave, it can be the wind. Okay, so those are the possible pressure, or I mean the possible forces acting on the dam. Okay, so these steps. So you need to determine the weight of the dam. So you have there just the properties of fluid that is equal to specific weight of water times it's not water, sorry. The specific weight of the material. If material of the dam is concrete, so that is the specific weight of the concrete. If the material is stone masonry, so you have to determine the specific weight of the stone masonry. I will use V nga na siya ikuan, because if I use the V like that, it can also denote as velocity. So that one, it means that is volume. Okay, so for getting the weight, you have that formula. So for the specific weight of the concrete, for example, the specific weight of the concrete, you just multiply the specific gravity by the specific weight of the water. The specific gravity of the concrete is 2.4. So you have to, dili manggaling siya class, ihatag ang specific weight of the material. Kung concrete manggaling, you have to go back to the basic. That is 2.4 times gamma of water. Kay base mangita mo mga value diha, then gihatag na siya sa inyong nakitaan diha mga kuan sa inyong study aid material. So inyo lang gi-copy. So ako kay mangita man ko kung say solution if it is not given. Tanan matters, no, sa ako at tanan class mo matter, dili siya inyong kuan ga tan-aw ko sa inyong answer, ga tan-aw ko sa inyong solution, giunsa ninyo pag-atake ang problem. So everything will be solved unless given siya. Kung dili siya given, you have to solve, you have to show me, dili kay mutungha ra diretso ng mga values. Okay, for the pressure, the same lang, you have ning specific weight. So uplift pressure sa tubig man ni siya, sa headwater o sa tailwater, so that is the specific weight of the water times the volume. Okay, so you have also that one. Then for the horizontal forces, we have wind pressure, we have wave, the floating bodies, you also have the earthquake load. So any forces acting on the dam, you have to consider. Then compute, after that one, you compute the load along horizontal and the load that is along vertical. So you have vertical reaction Ry, so that is the summation of forces, vertical forces. Then for the horizontal reaction, those are the forces. You have to sum up all the reaction along horizontal. So you need this one in order to determine the location of the resultant load, so that you will know what will be the distribution of the soil pressure, because not all the time that the pressure, no, lahi ng uplift lahi ng uplift pressure, lahi po ng soil pressure. So maybe we will say nga ang uplift parehara siya o soil pressure. It's not. Ang uplift pressure depende na siya sa imuhang headwater o sa imuhang tailwater. Imong soil pressure depende na siya sa location sa imuhang Ry, sa imuhang resultant. So you have to take note, because sa reviewers wala na gipang solve, nagipang neglect na diha tanan ng kuan. Laban ka neglect sa uplift pressure. Okay. Again, pa ko i-kuanday ninyo. If ever, although this one is uplift pressure, kung ilag siya sa inyong hangkuan, kung na siya tailwater, the uplift pressure is like this because you have seepage sa downstream of sa stream side. So, ang imuhang distribution sa imong seepage is trapezoidal. Pero, kung bisag wala na siya, pero ang problem mo siya nga, we will assume ang headwater ra mo but the problem states that you have to assume full hydrostatic force at the upstream side and full hydrostatic force at the two side or at the downstream side. So the distribution of the uplift is also look like this. That is in trapezoidal form. So, no? Okay. Ana, pero kung wala siya ni istorya class, since wala may tubig diri sa downstream, so that is zero. We have zero. So ayaw butangin ninyo og kuan seepage kay wala man kay tubig diha. So your distribution of your uplift is triangular. Basta wala kay water. Pero bisa kung naamang galing ng tailwater, siya nag-state dito, so ang imuhang kuan is trapezoidal. Depende na siya sa tanawa ninyo ang statement sa problem, tanawa po ninyo kung say itsura sa inyong figure or unsay gi-describe diha sa inyong problem. Okay, so next is to determine moment. So you have to identify unsa ang moment nga ni-resist, then unsa pud ang moment ni overturn. So looking back again sa inyo sa kuan, this figure sa ating reasoning uban. So looking back to that figure, so you have to identify what are the forces that resist, no? Help the dam to resist against overturning. And what are the pressure that overturn the dam? So looking back to this figure, so ang imuhang hydrostatic force, this one, so overturn na siya. Kapag mo nag-overturn pod. So muna siya imong overturning. Kung napak kay tailwater diha, you have another force, let that one force 1 and force 2. So, ang nag-resist na po mo is kani. That forces imong tailwater and also all the self-weight, or the weight of the dam. So, ang imuhang weight sa imuhang dam, imuhang manggi himay, binagsan nimo siya. So, it helps to resist the overturning, no? So inyo nang i-identify as a overturning moment or a writing moment. Then again, you determine the location of the resultant. So specific weight or specific gravity is 2.4. The specific weight of the concrete is 2.4 times gamma of water. So this is 2.4 times gamma of water. Okay, so once you determine the location of your resultant, so for example, if this is a cross-section of your dam and this is the center of the dam. So since nag-moment man ka sa 2, so that is the location, no? Ang imong reference sa imong location sa imong RY. So it can be your RY is that point. So that is the location of your RY. You have to determine kung ang imong RY diha dapita, so ang imuhang soil pressure diri dapita usgan na diha, nangusog na siya tungod kay diha laban ang imong load. Diri dapitas imong dili kayo siya kay layo raman ang imong resulta so hayahay. So your pressure can be like this. Pero naakay basis ani is trapezoidal because it can be also triangular. Depende na siya sa location sa imong RY. So later na lang ato nang i-discuss, no? So you need to know the location of the RY so that you will know the distribution of your soil pressure. Then, after determining the location of the RY, you have to check the factor of safety against sliding. So, if it is greater than 1.5, so it is safe. If it is less than, so you have to provide a shear key to resist sliding at the foundation of the dam. Then, for overturning, it should be greater than 2.0. So, if it is not safe, against overturning, you have to increase the dimension of the dam. Imong padakpan. Okay, again, this is the criteria for the distribution of the soil pressure. So this one is the pressure of your soil. So it is uniformly distributed for the entire base of the dam. Ano sa man ni mahitabo? If the location of the RI is at the center. So this is the center, no? Kani naa siya tunga. That is the location of your gravitational gravity, no? That is center of gravity. So diha na coincide ang imuhang location sa imuhang resulta. So to determine the pressure, this is the formula. So that is Ry divided by B. So ang pagkuha sa pressure. So equal, no? Equally distributed imuhang soil pressure. If the resultant is at the middle third, so imong bahinon og katulo ang imong, you have to divide it into 3. Then, kung naa siya sa imuhang middle third, so naa siya sa it's not 1/3, it's at the middle third. So, kung siya, ang imong RY naa sa pikas pod nga middle third, bali ning imuhang itsura, no, sa imuhang distribution ng ana. So, inyo nang timan-an ang sa dapit ang location kay dito mo pabor ang imuhang kung imong load na diha dapita sa nga side, so ang imong soil diha supporting pag-exert sa yang effort para mo resist ana nga load. So stressful kayo ang imuhang soil diha. So mo na siya inyong timailhan, you have to determine the location of the RY. Okay, so that is getting the area, and that is the area. Here is 0, so that is the area of trapezoid, no? Look like that. But here it is 0, so P is equal to 0 at that point. So that the Ry for the pressure here is equal to 2 Ry over B. So this is twice the average, no? Kay ang imuhang pressure is Ry over B. That is if you have a uniformly distributed. So kani siya kung naa siya sa imuhang middle third, so twice ang imuhang pressure sa imuhang uniformly distributed. Kung ang imuhang location sa imong Ry is at the middle third. Okay, so if it is outside, so again, mao ni siya location sa imong middle third, outside siya, so this is the formula. So, asagi ka ng ang formula, so mayroon kang stress, so stress is equal to P over A. So this is stress, this is load, so over A, area. So ang stress nato is the pressure. Then you have there the resultant over A. So Ry is equal to pressure times pauni mo ang kuan area. So you have P, diba? The area that is 1/2. So kung imuhang panon, ang area, so Ry, that is the load, that is 1/2 of P max times 3x. Wala na siya diyan. Pag-derive sa imuhang formula. You have to take note nga ang iyahang swell pressure distribution naa siya sa iyahang length nga 3 times x times the location. Bar x man eh. So 3 times the location of the Ry. So you have to take note that is triangular. Then if the resultant is within, so this is your middle third. So naa sa tunga-tunga within siya. So the formula now is a combine of axial and bending stress formula. So you have here the soil pressure distribution is trapezoidal. Again, ang imong location sa imong Ry doon siya sa two side. So diri ang dako gamay diha. If ang imuhang Ry na po naa sa kuan, naa diri dapit imuhang Ry, okay, so ana na po, so bali na po ang imong distribution. So we have here the formula for your stress. So you can say that this will be equal to murang ipagawas ang Ry over P. So that's in plus and minus 6A over P. Plus, kung naa siya diri, this is positive. Okay, that is the stress for positive. Balik sa ato ang kuan figure. So this is positive, this is Q max, and this is Q minimum. So ang positive mo ng Q maximum, ang minimum is the negative. Diba? So for example, if this is your structure, then you have here, this is the center. Okay, this is the center. Kung naa kay imong load na diha pita, so you have here an eccentric loading. So the moment there is equal to the distance from the center times the load. So that is the moment. Mo ni siyang kuan E times Ry ang formula. So again, kung ang imuhang load naa sa center of gravity, so kuan siya kanang nawa na kayo kuan po. Okay. 5%. Charge.
Excuse me, ma'am. Nag-block screen, ma'am.
Okay, I have here an example. So we have to check if the dam is safe against sliding and overturning. Then we have to determine also the soil pressure, no, the stress at the two or at the heel. So we need to determine the, when you say stress, it is also the soil pressure. Okay, so here, na-agree kita, we have to take note that it is full hydrostatic pressure at the two and full hydrostatic pressure at the heel. So the friction is 0.65, the coefficient of friction. Okay, so bisag unsa pa na nabo siya tubig sa downstream wala, mao ni ato ang i-consider. Pero kay mao may iyang ipagamit nato no sa problem. Pero kung wala na siya nga statement, so kung unsa sura sa inyong figure or yung sa pag-describe ang dam, so you have to solve all the forces acting on the dam. So we have here this one. So see, there is a tailwater at downstream side. So even wala na yung statement, but still the soil pressure, the cliff pressure have also full we have full hydrostatic at the hill, and we also have side. So if we have roll, so this is the hydrostatic pressure of your dam. So that is at the centroid. So we let that one as our F1. Here also you have the hydrostatic force, then located at the centroid, then you let that one as your F2. So here this is U1, and this is also your U2. Ano? Sorry. Uh, Again, this is your gamma times h. So here is also your gamma times h. And the pressure at this, with that is P2, this is your P1. This is also gamma times H2. This is H1. So, ang imo leaf pressure ani, ato ning i-divide, or kung kahibalo mo sa location sa imuhang centroid sa trapezoidal, pwede lang usa. No? Usa ra ka buok ang imuhang if you can compute the centroid. So kung wala, kung nag-ato siyang binagsaon, kanang easier for us to determine. Ato siyang so mas easier for us to know the location of the gravity of the rectangular section. So that is at the center. So maybe you can say that is your U1. And for the triangle, you can say also that is the U2. That is a fifth pressure 2. And that is the triangle, and it is located at 1/3. Or that is 2/3 from the 2. Then after that one, you have to determine what are the forces that is resisting or the writing moment, and what are the forces that can make your dam overturn. So here, your dam, you also have your weight 1, so you can also divide it. This is also your weight 2. But here, you have the water here. You can have that as weight 3. So, water na siya. What you need to do is to compute this one, this x. So, we need to compute the value of this x. So, pwede na siya, whatever the x here, pariha na siya diha na x. So, you can solve this ratio and proportion. So, this is your x. So, whatever the x there, this is also the x. Pwede lang na siya. So, we have, so this is 20. This is also 20. And this is the 20. And this is 16. 24. So 20 over 16. Then 2.4 is the x. X is equal to, we can compute. So the 20 over 16. 1.90. Okay, that's the value of your x. Okay, so after getting the weight, forces, mas maayo siya plus mo siyang i-tabulate. So this is akong igama. Have that one. So compute all the forces, mas maayo mo siyang i-tabulate. Then, this is just the difference, no? This one is just the difference of E1 minus E. Okay, so mas ayaw kung ito siya i-tabulate. So, ano siya i-tabulate, makita tayo nimo siya diretso kung if ever na kayo sa iyo bitaw na ano. Mas makipan ko ninyo nga yung i-tabulate the data to assess your solution para makita niyo yun asa mo masayot either sa moment out or silent computation sa weight. Careful lang po, okay, careful lang ako pag sa weight because the weight here is sa water. It's not just concrete anymore. Kani siya mo sa concrete, specific gravity control. But here, that is already water sa W3. So, okay. So, check. Then, for the moment arm, so for W1, okay, this is, that is 20. 20 minus 2, so that's 18. So, sa weight 1. Ang ilong weight, that is 2/3 of 2 sides, so that is ilang man na. So, 16. 16 man eh. 16. So, 16 is 2/3 of 16 over 3, so that is 32 over 3. Then, ang weight 3, that is 1/3 of x. X is 1.92. Then, ang F1 is of 18.8. 18.8 1/3. 18.8 divided by 3. Then, F2 is 1/3 of 2.4. So, F1, then U1, this is 2/3 of 20. 2/3 of 20. 2/3 of 20. So that is over 3. Okay, for U2, you have 1/2 of 10. 1/2 of 20. So, you have to determine kung sa mga resisting moment. So, sa resisting moment, yung F1 resisting. Ano? It's overturning. So, you have weight 1, weight 2, weight 3, and F2. Check resisting, weight 2, weight 3, and F2. So, for the overturning moment, you have F1, U1, F1, U1. So, you have to take total. So, total ako na, total na ako ang horizontal at ang vertical. So, from that, we can compute now the factor of safety against overturning and sliding. So, we found out that is less than 1.5, so that is not good. So, you have to put a here for the location of the RY. So, by default, this is your the location of the RY. So, this is the center. So, 20, that is 10. From the 2, this is 10. So, the location is 10.32. So, lapaw sa. So, we let this one. So, we have, this is your RY. This is the location of your RY. So, kung ato ni siyang i-divide into 3, so this is 6 point something, no? So, we divide it into 10, 20. So, 20 over 3, this is 20 over 20 over 3. So, within, no? It is within, your RY is within the middle third. So, the soil pressure distribution is trapezoidal because RY is in the middle third. So, all the way of the duct is under equal pressure. So, you have to take note of this because we need this whole portion at one by determining the soil pressure of the dam. So, we have here this one. So, since your RY, naadari imong RY sa imuhang hillside, so di have imong maximum pressure. So, the distribution is this one. You have here a trapezoidal. Pero, dako imuhang soil pressure sa imuhang hillside. Okay, so, to determine the pressure, you have the formula. Okay, that is 6M. Ganun ang formula natin, 6M na siya. Okay, so we can have this one, Ry over P, 1 plus and minus 6M. So, mag-compute na nimo ang moment, okay ba po? F, so, because this one and this F. So, you have Ry over P plus and minus 6. Okay. Sorry, not this one. Okay, this one. This one. So 6 and this one maybe also good. And this here. Okay, so that is the formula. So, remember lang positive mo Q maximum. So, ang Q maximum is naasa hillside. This one is 2. Okay? So, that's the computation for the soil pressure. So, in this problem, soil pressure and the hydrostatic force equal distribution, which is trapezoidal distribution for hydrostatic force and also trapezoidal distribution for the soil pressure. Okay, class? So, that's all for the problem. So, if you have any questions, you can tell me kung ano yung walang masaktan. Okay, nakasabot mo.
Okay,
I-observe pa mo. So, ako din out. Short mo nga. Dili mo mag-tulong. Dili mo magkaapas. Can you kindly on your camera? ako lang is, I hope you take note whatever things na istorya ninyo because dili kanan inyong tanawon na kuan. I know na amoy mga reviewers diha. Ako ninyong ubang reviewers akong istorya ninyo ron ang neglect ang pressure, and you have to take note that pressure is different from the social. Dili tanan na pareha ang imong pressure sa imong soil pressure. Muna siya masayupan in this problem because you're thinking it is the same with the soil pressure. So dili na siya pwede. Then you have to check kung unsay distribution sa imong soil. And also, you also have to check unsa ang imuhang mga uplift pressure. Kaya kung dili mo kawalo anak plus, one step lang no, sa sinugdan pa, dili mo kabalo anak. Kung makita na po na, you need to illustrate the problem. Kaya wala pa mo kasugod, na ko, no, pag drawing pa lang daan ninyo, kay balo na ko nga, di na ko pwede mo proceed kay sayop na inyong solution. So, again, you need to illustrate the problem and you have to show me what are the forces acting on the kay kung sayop inyong illustration, sayop inyong kay mag-solve man gud mo based man sa inyong illustration. So, kung sayop inyong illustration, di naman mo, sayop din na tanan, di ba? Kasabot pud mo ana. Di man pwede nga inyong illustration insakto dayon sayop inyong solution. Kung pwede nga naamoy solution, wala mo illustration. How come nga naamoy solution nga wala mo illustration? So you have to show me your solution and your illustration. Okay, so wala mo question? I know nga wala pa jud mo question kapaman mo gapon. So later on na manggawas na iyang question pag makatok. Pero try to cope up. Then I need your decision if mo exam pa ko ba kung exam matulong sa fluid mission or diretso na. So the coverage of final exam will be from the 8 stages of flow up to water hammer. Okay? So muna siya atong final exam na coverage. So wala may question, akong i-off na ni, then we will proceed katong sa theory. Para mas makakuha